With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let's start this question. Now what the question says, which of the following statement is correct? We are given 4 statements and we have to tell with the correct statement. Now we are given the first statement is number of subshell present in the M shell is 3. Now firstly we will discuss according to the Bohr theory. We know that there is one nucleus which contains neutrons as well as protons that are positively charged. Now outside this nucleus there are electrons revolving in certain stable orbits. Now Bohr gave the value of this orbits as m and n. Now this value of orbits is just analogous to the principal quantum number, that is n. Now the value of n for the K shell is 1 and L is 2, 3 and 4 and so on. Now this n tells about the number of shell. Now we have one more quantum number, that is the azimuthal quantum number. Now this quantum number tells us about the shape of subshell. Basically there are 4 classification. Firstly there are orbits. Inside the orbits there are shells, or we can say orbits are the shell, and this contains subshell which contains orbitals, and then they contain orbitals and then the electrons. Now this is the address of the electron in a atom. Now the value of orbit or shell is given by n, that is the principal quantum number, and the subshell is given by L, that is the azimuthal quantum number. Orbital is given by m, that is the magnetic quantum number, and the spin of electron is given by s, that is spin quantum number. Now we are discussing the azimuthal quantum number. It tells us about the shape of subshell. Now the value of L lies from 0 to n minus 1. It is 0 in case of S subshell, 1 in case of P subshell, 2 in case of D subshell, and 3 in case of F subshell. Now if we consider the value of magnetic quantum number, that is the value of M, it lies from minus L, that is to plus L. Now we are given number of subshell present in M shell is 3. Now we know that the value of n for M shell is 3, so the value of L can be 0 to 2, which will be 0, 1, 2. Now we know the value of 0 is for S, 1 is for P, and 2 is for D. Now it will contain 3 subshell, so this statement is correct. Now we are given the number of orbitals present in the N shell is 16. Now we are known to the principal quantum number of N shell, that is 4. N is equals to 4, so the value of L can be equal to 0 to n is equals 0 to n minus 1, that is 3. So it will be 0, 1, 2 and 3. Now we know the value of 0 is for S, 1 is for P, 2 is for D, and 3 is for F. So also we know the value of orbitals is given by the value of magnetic quantum number, which lies from minus L to plus L. This is the magnetic quantum number. Now for S, if we see the magnetic quantum number is azimuthal quantum number for S is 0, so the magnetic quantum number for S will be also 0. Now for if we write for P, the magnetic quantum number will lie from minus 1 to plus 1. So it will have minus 1, 0 and plus 1. For D it will be, the value of M will be minus 2 to plus 2. So it will contain minus 2, minus 1, 0, plus 1, plus 2. And for F, the value of magnetic quantum number will be minus 3, 2, plus 3. That will contain minus 3, minus 2, minus 1, 0, plus 1, plus 2 and plus 3. So this is the magnetic quantum number, which will be equal to the number of orbits. Now if we consider number of orbits in case of S will be 1, that is M is equals to 0. In case of P it will be 1, 2, 3. In case of D it will be 1, 2, 3, 4, 5. And in case of F it will be 7. Now if we add them, it will be 7 plus 5, 12 plus 3, 15 is plus 1, 16. So there will be 16 orbitals in total. that is the second statement is also correct. Now we are given copper positive having the atomic number as 29 is paramagnetic. Now we will firstly write the electronic configuration for copper positive. Now firstly we will write it for neutral ion of copper, that is Cu. It will be 1s1, 1s2, 2s2, 2p6, 3s2, 3p6, 4s1 and 3d10. So this is the electronic configuration for copper. Because it has fully filled stable d orbitals, the value of electron in 4s is 1 and 3d is 10. This is the exceptional electronic configuration. Now if we write the electronic configuration for Cu positive, it will be same, except the last it will have 4s0 and 3d10. The rest will be same. Now this is stable, and if we draw d orbitals, it will be 1 2 3 4 1 2 3 4 5 6 7 8 9 10. So the number of electrons are 10 and they are fully filled. All the electrons are paired. That means that it is diamagnetic in nature. Diamagnetic. Paramagnetic nature is shown by unpaired electron. Diamagnetic nature. So this is incorrect. Now we are given the fourth option. Zeeman effect explains the splitting of spectral lines in magnetic field. This is correct. Zeeman effect explains the splitting of spectral line in magnetic field, whereas the Stark effect, this tells us about the splitting of spectral lines in the electric field. So these are the correct statement, that is A, B and D. Thank you so much.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.